Hi, welcome to this Corbettmaths video. In this video, we're going to look at how to solve index equations. So how to solve equations where the unknown is an index, it's a power. So here we've got solve 8 to the power of x is equal to 50. Now, using our knowledge of powers, we know 8 to the power of 1 is equal to 8, and we know that 8 squared is equal to 64. So our answer is going to be in between 1 and 2, but we need to solve this and figure out what the power will be. So we can use our knowledge of logarithms to help us. So one approach we can use to solve this is to take the logs of both sides of this equation. So we can take the log of the left-hand side, so that'll be log of 8 to the power of x, and then that'll be equal to the log of 50. Now, we want to find out what x is. So remember our laws of logarithms. If we look at that third law of logarithm, that if we've got a power, we can bring it down. So here we can bring this power down, this x down. And if we do that, we'd get x times the log of 8 is equal to log 50. So we've taken the logs of both sides, we've then brought the power down, so we've now got x times log 8 is equal to log 50. Now we want to solve this equation to find out what x is, so we're now going to divide both sides of this equation by log 8. So we're dividing the left hand side by log 8 to get rid of the log 8, so we'll just be left with x, so we're going to get x on the left hand side. On the right hand side we've got log 50, and we're going to divide that by log 8, so we have log 50 divided by log 8. So we've now got that x is equal to the log of 50 divided by the log of 8. So on our calculator, we're just going to type this into our calculator and see what we get. And if we take the log of 50 and divide it by the log of 8, we get an answer of 1.88128539. So that means the x, the power here, would be equal to 1.88128539. And if we just round that, let's round that to 3 decimal places. So the 3 decimal places, x would be equal to 1.881 to 3 decimal places, and that's it. So we've solved this equation by taking the logs of both sides. So we've taken the logs of both sides of the equation, we've brought the power down, and then we've just divided both sides by log 8, and we've worked out that division, and we've found what x is, and that's it. Now, another approach we can use to solve this equation is just to consider the fact that this is an index form and we want to write it as a logarithm. And this would work because in this equation we've just got the x as one power, we've got the unknown as a power here of the 8. If you had on the right hand side 8 to the power of x is equal to 50 to the power of x plus 7, then this approach may not be as useful, but this is quite useful whenever you've just got the x on one of the powers like so. So here, if we take this, it's an index form, we write it as a logarithm. So we've got the base, the power, and the answer. So the log, the base, that's base 8, of the answer, which is 50, would be equal to the power, which is x. So remember, whenever we're dealing with logarithms, we're saying what power do we raise the base by to get the answer. So in other words, what would we raise 8 to the power of to get 50? So we know that x, it would be equal to the log to base 8 of 50. And we can just turn this around, so x would be equal to the log base 8 of 50, and now we can just type this into our calculator. We can just work out the log of base 8 of 50, and we'll get the same answer as we did before. So the log to base 8 of 50 is equal to, x is equal to 1.88128539, and that's it. And we could round this to 3 decimal places to get x would be equal to 1.881 to 3 decimal places. So that's another approach as well, just taking what we had in index form and writing it as a logarithm, and then just working out what log base 8 of 50 would be, and the log to base 8 of 50 would be equal to 1.8812 and so on, and that's it. We've worked out what x is, the power. So that's another approach that we could use to solve that equation. So one approach is to take the logs of both sides, and I like that approach because later on in this video you'll see that that's quite useful, but also you could just rewrite this, which is an index form, as a logarithm and work it out. Okay, let's have a look at another question now. Okay, let's look at our next question. So our next question says, solve 7 to the power of x is equal to 300. So we need to work out what this power would be. Now I know that 7 squared is 49, and I know that 7 cubed is 343. So this power is going to be in between 2 and 3, but we need to solve it and figure out what this power will be. So again, we could use, for this particular question, we can use either approaches. So let's take the logs of both sides to begin with. So the log of the left hand side would be the log of 7 to the power of x is equal to the log of the right hand side, so the log of 300. Now let's bring our power down, so that'll be x log 7 is equal to the log of 300, and I just use that third law of logarithms, the fact that if you have the log of x to the power of n, you can bring that power down. And then if we want to solve this, we can now divide both sides of this equation by log 7. So let's do that. So let's divide both sides by log 7. So if we divide the left hand side by log 7, we'd just be left with x, and if we divide the right hand side of this equation by log 7, we'd have the log of 300 divided by the log of 7. And when we work that out in our calculator, we'll take our calculator, we'll take the log of 300 and we'll divide that by the log of 7, and we get that x is equal to 2.9311644359. And we can round that, let's round it to 3 decimal places, so x is equal to 2.931 to 3 decimal places. And that's it, we've solved that equation, and we've taken the logs of both sides, we've brought the power down, and then we've divided, and we've worked out what x is, the power. And that's it. There's also another approach we can use to solve this equation, and that's the fact that this is an index form. We could just rewrite it as a logarithm. So we'd do the log of the base, which is 7, of the answer, which is 300, is equal to the power, which is x. Because remember, as a logarithm, we're saying what power do we raise 7 by to get 300. And now we can just turn this around. And then if we just type that into our calculator, the log to base 7 of 300 is equal to x is equal to 2.931164359. And again, we could round that to 3 decimal places to get 2.931. And that's it, we've worked out the power there, and that's it. Okay, let's have a look at another question. Okay, let's look at our next question. So this time we've been asked to solve 9 to the power of x is equal to 2. So we want to work out what this power is. Now I know that 9 to the power of 0 is equal to 1. I know that 9 to the power of 1 is equal to 9. So this is going to be in between 0 and 1. Actually, I know that 9 to the power of a half, the square root of 9, is equal to 3. So I know that this power is going to be in between 0 and a half. So let's work out what it's going to be. So let's take the logs of both sides of this equation. So the log of 9 to the power of x would be equal to the log of 2, just taking the logs of both sides of that equation. Now let's bring our power down. So we've got the x log 9 is equal to log 2. And then finally, let's divide both sides of this equation by log 9. So we're left with, on the left hand side, x. And on the right hand side, we'd have the log of 2 divided by the log of 9. So let's work out what that is. So if we take our calculator and we do the log of 2 and we divide that by the log of 9, that's equal to 0.315464878. And we could round this if we wanted to, and that's it. That's the power. That's what x is. X is equal to 0.31546 and so on. And again, you could round it perhaps to 3 decimal places to get 0.315, and that's it. So we've solved that equation, just taking the logs of both sides, bringing down the power, and dividing both sides by log 9. Again, with this one, we could write it as a logarithm instead. So this is an index form. We've got 9 to the power of x is equal to 2. So we've got the log of the base, so the base is 9, of the answer, which is 2, would be equal to the power, which is x. So we want to figure out what power do we raise 9 by to get 2. And then we can just turn this around and get the log to base 9 of 2. And if we type that into our calculator, we get that x is equal to 0.31546 and so on. So we get that same answer. And that's it. So we've solved that equation. Okay, let's have a look at our next question. So this time we've been asked to solve 5 to the power of 2x is equal to 40. So this question is a little bit different than the ones before, because before we just had a power of x, and this time we've got a power of 2x. But that's okay, we can still solve the equation using the techniques we've talked about. So let's take the logs of both sides. So the log of the left hand side, so the log of 5 to the power of 2x, will be equal to the log of 40. Now we want to bring down the power, so let's bring down the power here. So that would be 2x multiplied by log of 5, just bringing down the power, and the power was 2x, so we're just bringing that down. So we've got 2x multiplied by log 5 is equal to log 40. Now we want to solve this, we want to find out what x is, so let's get rid of this log 5. So if we divide both sides by log 5, on the left hand side we'd be left with 2x, and on the right hand side we'd have log 40 divided by log 5. So let's type that into our calculator, log 40 divided by log 5. And when we type that into our calculator, we get an answer of 2.292029674. So we've got the 2x is equal to 2.29 and so on. But we want to solve this. We want to find out what x is. So we now need to divide by 2. So if we divide both of these by 2, we're going to get that x is equal to, and if we divide this by 2, we get an answer of 1.146014 and so on. And to 3 decimal places, we find that x is equal to 1.146. And that's it. So we've solved this equation. We found that x is equal to 1.146 to 3 decimal places, to 3 decimal places. And that's it. So we've solved that equation. So this time in this equation, our power wasn't just x, it was 2x. And we just solve it using the same technique, but we just make sure that whenever we're bringing down the power, we're bringing down that 2x. And then at the end, we need to divide by 2. Now, also with this question, because we've just got that one power with involving x, we can then just write this, which is in index form, as a logarithm. So we've got 5 to the power of 2x is equal to 40. So we've got the base, the power, and the answer. So the log to base 5, so log to base 5 of the answer, 40, will be equal to the power, which is 2x. And then we can turn this around to get that 2x is equal to log to base 5 of 40. And then if we just type this into our calculator, the log to base 5 of 40, we get what that's equal to. So on the left hand side we'd have 2x, and on the right hand side we'd have that's equal to 2.2920296 and so on. So we've worked out the log to base 5 of 40. Now we want to solve this and find what x is, so we just need to divide by 2. And if we divide both sides by 2, we get that x is equal to 1.146014 and so on. And again, we could round that to 3 decimal places to get that x is equal to 1.146 to 3 decimal places to 3 dp. And that's it. So we've solved that equation by taking the logs of both sides and bringing down the power, or we can rewrite this, which is an index form, as a logarithm and then solve it. Again, I like to use this approach because as I said, later on in the video, we'll see some questions where this is particularly useful. Okay, let's look at our next question. Okay, so this time we've been asked to solve 12 to the power of negative x is equal to 70. So again, let's take the logs of both sides. Again, the power here isn't just x, it's now minus x, but we'll use the same approach. So let's take the logs of both sides. So the log of 12 to the power of negative x is equal to log 70. Just taking the logs of both sides. Now we're going to bring down our power. So our power is negative x, and if we bring that down, we get minus x log 12 is equal to log 70. Just bringing down that power. Now at this point, we want to get the x on its own, so let's divide both sides by log 12 to get rid of this log 12. So on the left-hand side, we're going to have minus x, and on the right-hand side, we're going to have the log of 70 divided by log 12. So the log of 70 divided by log 12. So we've taken the logs of both sides, we've brought down the power, and then we've divided both sides by log 12. So we've now got the minus x is equal to, and if we type this into our calculator as a fraction, the log of 70 divided by the log of 12, close brackets, and we get that's equal to 1.70972 and so on. But that's minus x. We don't want minus x. So at this point, you could just multiply both sides by minus 1 to get that x is equal to minus 1.70972 and so on. Or another approach would be to say, well, you've got minus 1 times x, so then if you divide both sides by minus 1, and then you get the same answer anyway, you get that x is equal to minus 1.70972, and so on. And that's it. We've solved this equation. We've worked out what x is. X would be equal to minus 1.70972, and so on. And that's it. Again, if you had this equation, 12 to the power of negative x is equal to 70, well, you got something in index form. You could rewrite it as a logarithm. So you've got the base, the part, and the answer. So the log to base 12 of the answer, which is 70, is equal to the power, which is negative x. And then you can just solve this. We could then turn it around to get minus x is equal to the log of base 12 of 70. We could work this out in our calculator to get the minus x would be equal to, and if you work out the log to base 12 of 70, you get that's equal to 1.70972 and so on. And then this is minus x, so you can then just divide both sides by negative 1 or times both sides by negative 1, and you get that x would be equal to minus 1.70972 and so on. Or you could just change the signs, change both of the signs out, and then you get that. And that's it. So we've found out what x is. So again, we could take the logs of both sides and bring down the power, or alternatively, you could rewrite this, which is an index form, as a logarithm. Okay, let's have a look at our next question. So our next question is to solve 6 to the power of 2x plus 1 is equal to 34. So this time we've got a power of 2x plus 1. So rather than just being x or minus x or 2x, we've got a power of 2x plus 1. So let's solve it by taking the logs of both sides. So the log of the left-hand side would be the log of 6 to the power of 2x plus 1 is equal to the log of the right-hand side, so the log of 34. Okay, now let's bring down our power. So our power is 2x plus 1. Whenever I bring this down, I'm going to put it in a bracket so that I've got in brackets 2x plus 1 and then log 6. So I'm bringing it down and putting it in a bracket because I don't want to mistakenly read it as 2x plus 1 times log 6. I want to make sure that I know this is the whole power multiplied by log 6. And that's equal to the log of 34. So I've just taken the logs of both sides and brought down the power, but put the power in a bracket because there's more than one term there. Now at this point, we want to find out what x is. So we could expand the brackets if we wanted to, because then that would give us 2x times log 6 plus 1 log 6, or log 6 is equal to log 34, and then we could take away the log 6 from both sides and so on. So that's one approach. I personally, if I was solving this equation, would just divide both sides by log 6 at this point, because if I divide both sides by log 6, on the left hand side I'd just be left with 2x plus 1, and on the right hand side I'd have the log 34 divided by the log of 6. So we could expand our brackets, but instead I've just divided both sides by log 6. So then on the left hand side we'd still have 2x plus 1, and on the right hand side I'm going to work out the log of 34 divided by the log of 6. So the log of 34 divided by the log of 6, and that's equal to 1.968099282. So we've worked out what this is. We want to solve this equation and find out x, so we now want to get rid of this plus 1 and multiply by 2. So let's take away 1 from both sides. So if we take away 1 from the left hand side, we'd just be left with 2x, and on the right hand side we'd have 0.968099282, and we don't want this multiplied by 2, so let's divide by 2 and divide by 2, and if we then divide by 2 we get an answer of 0.48404996, and so on. So that's it, we've worked out what x is. X is equal to 0.48404996, and so on, or you can just round it to 3 decimal places to be 0.484. And that's it, so we'll find out what x is. Okay, so that was one approach to take the logs of both sides. In this equation too, because we've just got the 1 power here, this x in the 1 power, we can rewrite this, which is an index form, as a logarithm. So we would have 6 to the power of 2x plus 1 is equal to 34. We've got the base, the power, and the answer. So the log of base 6, the log of base 6 of the answer would be equal to the power, which is 2x plus 1. We would then, well, I'd probably just turn this around to get 2x plus 1 is equal to the log of base 6 of 34. And then at this point, I'd work out what the log to base 6 of 34 would be. So we get that 2x plus 1 is equal to 1.968099, and so on. I would then take away 1 from both sides to get the 2x is equal to 0.968, and so on. And then divide by 2 to get that x is equal to 0.484, and so on. And that's it. So we've worked out what x is. We just rewrote that as a logarithm and then just worked it out. Okay, so let's have a look at our next question. So our next question says solve 6 to the power of 4x plus 3 equals 5 to the power of x. So this question is a bit different than the ones we've looked at so far, because all the questions we've looked at so far, we've had the unknown as just one of the powers, but here you can see the unknowns on both of the powers. So this time, we're not going to rewrite this as a logarithm. We're going to be using the approach where we're taking the logs of both sides, and we're just going to use that one approach for solving this question. So let's take the logs of both sides of this equation. So we'd have the log of 6 to the power of 4x plus 3 is equal to the log of 5 to the power of x. So we're just taking the logs of both sides. Okay, now the x's, the unknowns, are on the powers. Let's bring those down. So let's bring down the powers. So here we're going to bring this power down. I'm going to put in a bracket. So we've got 4x plus 3. And then we've got our log 6. And then that's equal to, and then bringing down the power, we'd have x log 5. So we've taken the logs of both sides of this equation, and then we've brought down the powers, just making sure we've put this one in a bracket. Okay, so now we've got an equation and we've got x's on both sides. So let's expand our brackets here. So we've expanded these brackets on the left hand side. 4x times log 6 would be 4x log 6. And then we've got 3 times log 6, so that's plus 3 log 6. And on the right hand side here, we've got x log 5. So we've got x log 5 there. So as you can see, we've just expanded those brackets and we've got 4x log 6 plus 3 log 6 is equal to x log 5. Now at this point, we've got an equation with letters on both sides. Let's bring all the letters to one side. So we want to bring all the x's to one side and anything without letters to the other side. So what I'm going to do is I'm going to get rid of this number from this left-hand side. So I'm going to take away 3 log 6 from both sides. And I'm just writing it down here, what we're doing. We're taking away 3 log 6 from both sides. I'm just writing that down so you know clearly what I'm doing here. So on the left-hand side, I'm taking away the 3 log 6 to get rid of it. So I'll just be left with 4x log 6 on the left-hand side. And on the right-hand side, we had x log 5. We're taking away 3 log 6. So it's going to be x log 5, or x times log 5. Subtract 3 log 6. Okay, so we've taken away the 3 log 6, but we've also got this term with x on the right-hand side. So now let's take away that from both sides so that we have just the terms of x's on the left-hand side and the numbers on the other side. So if we take away x log 5 from both sides, so take away x log 5 and take away x log 5. So on the left-hand side, we'd have 4x log 6, so 4x log 6, subtract x log 5, x log 5. And on the right-hand side, we'd just be left with our minus 3 log 6, so minus 3 log 6. Okay, we're nearly there. Now, at this point, we could work out what 4 log 6 is and write that as a decimal number of x's, and then we could subtract and we can work out what log 5 is a decimal, and then take away that number of x's away from that number of x's, and you'd have a certain decimal number of x's equals this, and you could solve that. I probably would just want to factorize here. It's a wee bit tidier. So I'm going to factorize this left-hand side. I'm going to take the x out. So if I take the x out on this left-hand side, I'd have x and then in brackets, and just taking the x out of both of those terms, I'd have 4 log 6, so 4 log 6, and then subtract, and then taking the x out here, I would have log 5, and then close brackets, and that's equal to minus 3 log 6. So just factorize this left-hand side. Now we're almost there. We want to work out what x is, so we can now divide both sides by 4 log 6 subtract log 5. We could just divide both sides by this. So we'd have on the left-hand side x, and on the right-hand side we'd have minus 3 log 6, and then we'd have this on the denominator because we're dividing by 4 log 6 minus log 5. And then we could just type this into our calculator and see what we get. So if we work this out, and we get x is equal to minus 0.96719, and so on. And we could round that perhaps to 3 decimal places to get that x is equal to minus 0.967 to 3 decimal places. And that's it. So in this question, we had x's on both of the powers, so we took the logs of both sides. We brought the powers down. We then made sure that we expanded our brackets. We then brought all the terms with x's to one side and all the terms without x's to the other side. We then factorized it, and then we then divided both sides by that bracket to find out what x was. And that's it. Okay, let's look at another question. Okay, let's have a look at another question. So this time we've been asked to solve 8 to the power of x plus 2 is equal to 9 to the power of x plus 1. So again here we've got an index equation and we've got unknowns in both powers. So what we're going to do is we're going to take the logs of both sides here. So the log of 8 to the power of x plus 2 is equal to the log of 9 to the power of x plus 1. We're now going to bring down our powers, and remember to put those in brackets. So bracket x plus 2, close brackets, log 8 is equal to, and then in brackets x plus 1, close brackets, log 9. Okay, so we've brought down our powers. Now let's expand our brackets. So x times log 8 will be x log 8, and then 2 times log 8 will be plus 2 log 8. And then on the right hand side, x times log 9 will be x log 9. And then we've got 1 times log 9, so it's going to be plus log 9. So we've brought down our powers and expanded our brackets. And we've got x log 8 plus 2 log 8 is equal to x log 9 plus log 9. Now at this point, we're going to bring all the terms with x's to one side and everything else to the other side. So I'm going to bring all the terms with x's to the left-hand side here. So I'm going to take away, I'm just going to write this out just so you know what I'm doing here. I'm going to take away x log 9 from both sides. So I'm going to take away x log 9 from the right-hand side, and I'm going to take away x lots of log 9 from the left-hand side. So on the left-hand side, we would have x log 8 plus 2 log 8 subtract x log 9. And then on the right hand side, we'd just be left with our log 9. So we've just subtracted x log 9 from both sides of that equation. Now if we have a look at our equation, we've got this term involving x's and this term involving x's on the left hand side, but this term doesn't involve any x's. So now let's take away 2 log 8 from both sides. So let's take away 2 log 8 and take away 2 log 8 from both sides of that equation. So on the left hand side, we'll be left with x log 8. We've taken away the 2 log 8 to get rid of it, so then we'll just then have minus x log 9, and then on the right hand side we'd have log 9 subtract 2 log 8. This is fantastic. On the left hand side we've got terms just involving x's, and on the right hand side we've just got terms involving numbers. So now let's factorize this left hand side. So we'd have x and then brackets log 8 subtract log 9, just taking the x out there as a common factor, is equal to, and then the right hand side, log 9 subtract 2 log 8. And then finally we just need to divide. So we just want to get the x on its own. We don't want x times this. We're just going to divide both sides by this bracket. So if we divide the left hand side by this, we'd just be left with x, and then the right hand side we'd have, this would be our numerator, log 9 subtract 2 log 8, and then on our denominator we'd have log 8 subtract log 9, just dividing both sides by that bracket. And then if we type this into our calculator, x is equal to 16.6548478, and so on. And that's it. We've solved that equation. So just to recap, what we done was we took the logs of both sides, We brought down the powers and we made sure we included those in brackets. We expanded our brackets. We then brought all the terms involving x to the one side and all the terms that don't involve x to the other side. We then factorized the side with the terms involving x and then divided, and then we worked out what x was, and that's it, and we found x to be 16.654 and so on. And that's it. So in this video, we've looked at how to solve index equations, so equations involving unknowns as the powers or the indices, like so. We've looked at how to solve some quite straightforward ones like this, where we can take the logs of both sides and then we can bring down the power and then just divide both sides by, in this case, it would be dividing both sides by log 8 to find out what x would be. Or in this case, you could just rewrite this, because it's in index form, as a logarithm. And then we've looked at how to solve some slightly more complicated index equations, so where we've got the unknowns on both powers. And in this case, I would definitely want to take the logs of both sides, bring down the powers, expand the brackets, and then bring all the x's to one side, everything else to the other, factorize, and then solve it and find out what x is. And that's it. So we've looked at how to solve those index equations. And that's it.